Hi guys and welcome back to the channel. In last week's video we looked at how you can accelerate your data science workloads using Dataiku on top of Snowflake by working through one of Snowflake's Quickstart labs. That was done quite a while ago and we're using a data set that's live on Snowflake's data marketplace, so it's changing constantly, and as a result of that we ran into some issues as part of that. So if you missed part one, click on the link above, go back, take a look at that as we work through the lab. I reached out to my friend Stephen Franks back in London, who works for Dataiku. He originally put together that lab for Dataiku. He kindly took some of his time, was able to recreate the error and provide a workaround as well, which I've dropped into the comments below. And in this video, we complete what we started last week. So we finish up the Quickstart lab, we get over that error, we write the results back into Snowflake, and then we use some of Snowflake's functionality around cloning to create a non-production environment as well as time travel. So stick to the end of the video to take a look at that. And don't forget, if you get good value from this, drop me a comment below, give me a like, and don't forget to subscribe because new videos coming soon. Okay, so we're going to pick up the Quickstart tutorial from the point where we had the failure of the overflow of the data type in part one. Thanks to Stephen, now we've got a solution which I'll also post in the description beneath the video. But essentially, to carry on using Snowflake's pushdown and using the in-database SQL variant to score your model, you can simply change the storage types of big int columns to doubles, and that will make sure that your data types don't overflow it. Interestingly, that data set is changing all of the time. It's in Snowflake Data Marketplace, which means it's live, it's refreshed regularly. I've actually just recreated the entire Quickstart tutorial from scratch and scored the model, and I didn't actually get that error anymore. So you may be lucky and you might not come across it, but if you do get that same error, take a look in the description and I'll provide the link to how you can change your big int columns to doubles as well. So then we're going to switch back to the Snowflake table where we've just written the predictions. And we're going to run the following SQL first of all to set the context. Next, we're going to use the show tables like command to find our table. So there it is, test underscore scored underscore COVID-19. And we're going to select the records from that table. And here you can see our data where we've got our country region, our province state, and our date. We've got the variables that we use as part of the model and the prediction itself. If we go right across to the right hand side, we can see we've got our individual prediction scores as well. So next up, we need to create an environment for the testing team. And to do this, we're going to use cloning within Snowflake. If you're not familiar with what clones are, they're also referred to as zero copy clones. And that allows you to create a copy of tables or schemas or databases in a matter of seconds. It takes a snapshot of the data that's present at the time the source object is cloned, and then it's made available to other users. Now, if you want more detail about that, I'll put a link up in the top of the screen to a previous video I did around cloning, which will give you the key kind of points in a bit more detail. The real benefit of this is if you need to create a non-production environment for testing purposes or development, then this is a huge benefit to have zero copy cloning out the box from Snowflake. The underlying data is not copied, there's no physical data movement, it's just a logical metadata pointer to the underlying data itself. So that's why it's called zero copy. There's actually no data movement. That means that you're not storing that physical data again unless you decide to make a copy to that cloned data. And yes, it is writable as well, and your clone is writable. If you do decide to change your clone data, then obviously you will start to incur storage costs as part of that as well. So next up, we're just going to run this bit of SQL here, just setting the role, context, and the warehouse and database. If you've used this code previously within your query session, you don't actually need to run it again, but for completeness, I'll just show you. And then we're going to create a database, and essentially what we're doing is we're creating a database called Dataiku underscore test underscore DB. Notice the keyword clone here. And what follows is what we want to anchor our clone to. So basically we want to take a copy of this entire database, PC underscore Dataiku underscore DB, and call it Dataiku test DB. This is going to create that exact copy of the database at the point in time we're executing the query, i.e. now. No physical data movement. It's literally a metadata operation behind the scenes, and you can see that's completed in less than 7 seconds to copy all of the data across. If I hit refresh here, you'll see I have what looks and behaves and feels like a physical database. Essentially, though, it's a logical pointer to all the tables in this database as well. And this means now your development team or test team can do whatever they want with those tables, including deleting, changing the records. As I mentioned, it's a writable copy as well. It doesn't have any impact at all on your production database or any other object in that environment. Okay, and finally the Quickstart tutorial on the Snowflake website that we're continuing working through concludes with a small section around using time travel. And if you're not familiar with Snowflake's time travel capability, this allows you to access historical data within a table at any point in time, depending on what your retention period is set to. So the default period of time is 24 hours. So in the background, as you're working with data in Snowflake's tables, it will track changes without you having to do anything by default for 24 hours. And you can query that data at a point in time, which I'll show you in a second. The maximum amount of data retention time for time travel in Snowflake's Enterprise Edition can be up to 90 days. So this is a really handy functionality to see how data looked at a point in time, especially if you're troubleshooting ETL processes that failed, for example, and you want to see what the data was like pre and post that ETL process. Then this is really helpful for that. I'm not going to go into any more detail. I'm not going to show you how it works, but if you're interested in finding out more, I'll put a link at the top of the screen so you can have a look at that and check it out yourself. And as we'll see, one really interesting feature of using time travel is there's actually an undrop command. So if somebody mistakenly dropped a table, you can actually undrop that table and restore it. So let's show you how this works. So again, just for completeness, setting the context of the database in the schema, we're going to drop the table. And imagine if somebody did this, a user did this in your environment and dropped a table by accident. If you then came along to try to select, let's say, the top 10 records from this table, you would obviously get an error, and Snowflake would tell you that it doesn't exist or you're not authorized to view that particular object. So in that case, you can simply use the undrop command and place the table name in there. You can undrop it. That actually restores the table in the background instantaneously. Again, it's a metadata operation, and then if we select our top 10 records, there they are. There's a lot more detail to both cloning and time travel. Check out my other videos on that. It goes into a little bit more detail, and if you're interested in finding out more, drop me a comment below and connect with me on LinkedIn. Hopefully you found that useful, and obviously we touched on a little bit of Snowflake functionality at the end there, and as I mentioned, I've provided the links in the description and in the pop-out banners during the video as well if you want to find out more details about those. Dataiku also now leverages Java UDFs within Snowflake, which is a feature that's came out since that Quickstart tutorial was put together by Snowflake and Dataiku, so there'll be a newer one coming soon. If you're interested in seeing a follow-up demonstration using jar files and using Java UDFs within Snowflake and Dataiku and how that can accelerate your data science workloads, then please drop me a comment below. And again, don't forget to like and subscribe. New videos coming weekly.